Now we are going to demonstrate the spectrum analyzer. This is an equipment. Here you can see this is the equipment of the spectrum analyzer. GW Instec is the part number, GSP 830. This spectrum analyzer is running from 9 kilohertz to 3 gigahertz. This have the two separate port. The first port is called as a tracking generator. This port is called as a detector. These are the general panel bars are there. This is the keyboard from 0 to 9. The keyboards are there. There is a button called as the enter. Then also there is a special button. Rotary buttons are there. Then there is an up down button. This green color button is related with your power, and this is your screen. But before entering to the spectrum analyzer, we are now discussing about the basics about the spectrum analyzer. Generally, if you see now in these days, in so many cases the spectrum analyzer is going to be applicable. Like you see in this is the first poster where this soldier is having some log periodic antenna, and the one end is connected to the detector of the spectrum analyzer. He is detecting a wideband spectrum which is available in the vicinity of this soldier. So the spectrum analyzer, the first application is to locate the various spectrums available in the vicinity, and that's why the most of the peoples are utilizing antenna with the spectrum analyzer to locating their spectrums with their power. The second application, here you can see this is the GSM tower is there. This is the antenna of GSM tower. On the BTS tower, this spectrum analyzer they are connecting in front of that and try to measure the channel power. In the GSM band, then in every channels they have some certain powers they have to transmit. So the channel power transmission they also acquires on this screen. So here also they are seeing the signal to noise ratio of this particular band. So in the spectrum analyzer, not only we calculate the vicinity spectrum, but also signal to noise ratio or channel to noise ratio we can calculate by using spectrum analyzer. Apart from this, you can see here the harmonics and spurious content of the signal, it can be analyzed. Second, the width of the signal when you modulate it, it is going to be different. So here also there is a chance to calculate the Q factor of the signal is also possible by using spectrum analyzer. RF signal source also it is there in the transmitter, including in cellular, Wi-Fi and other radio and wireless application. You can analyze these types of sources and their properties by using spectrum analyzer. The radiation of unwanted signal will causes the interference to other users of the radio spectrum. This application also we can counter by using a spectrum analyzer. Means we can calculate the unwanted signal, what is the power, what is the frequency. This is the conclusion and bottom line of the spectrum analyzer. Basically, spectrum analyzer, this is a frequency domain device. There are two types of device. One is a time domain, second is a frequency domain. Most of the peoples are using a digital oscilloscope, DSO, which is the time domain. Having the once at x-axis the time is there, y-axis magnitude is there. But in frequency domain, x-axis is the frequency and y-axis is your power. So in any complex signal, suppose this is the signal, red color, having so many signals are added is there, means the matter is very much complex. If you look in the time domain, you are getting the blue color lines plus this high frequency line plus this line. So if you add it three lines, three different wave, you will get your complex one. So to analyze or to made it in representation in the frequency domain, this line have the lower side frequency, and this wavelength you can see this is very small. That's why in the frequency scale it is an upper side, but the magnitude is also less. So the content is also less, and the last one is also a high frequency. Again the wavelength is very small, so frequency is high, the magnitude is as much. So this red color contains three frequency components: blue color, green color and lavender color. So the three components in the time domain we are adding in the frequency domain. This frequency domain representation comes from the first Fourier transform. In the generally in spectrum analyzer, here we are utilizing various kinds of fast Fourier transform. In the second video, we are going to demonstrate the features related with the spectrum analyzer. Thank you.